Welcome everyone. I'm excited to kick off today's presentation on ServiceNow GlideRecord. Today, we'll explore how this powerful tool can help you handle data more efficiently. On this first slide, you'll see the title, Created by AI, ServiceNow GlideRecord, your guide to efficient data handling. Over the course of this session, we'll cover key concepts, best practices, and practical tips to make your data management smoother and more effective. Let's get started. Now, let's take a look at slide 2. Here, we see the outline of our upcoming topics. We start with an introduction to GlideRecord, which is the foundation of working with records in ServiceNow. Then we move on to creating and initializing GlideRecord objects, followed by querying records effectively. Next, we'll explore traversing result sets to handle multiple records. After that, we'll discuss inserting, updating, and deleting records to manipulate data. Then, we'll look into advanced techniques to extend what we can do with GlideRecord. Moving on, performance optimization is critical to ensure our scripts run efficiently, especially as data grows. And finally, we'll wrap up with best practices and tips to help you get the most out of GlideRecord in your projects. Throughout this presentation, remember that understanding these key points will empower you to work smarter and more effectively with data in ServiceNow. Welcome to our introduction to GlideRecord. In this part, we're going to explore what GlideRecord is and why it's such a powerful tool within the ServiceNow platform. Essentially, GlideRecord provides a simple way to interact with your database tables directly from scripts. It allows you to create, read, update, and delete records, what we often call CRUD operations, using a straightforward API. This means you can write scripts that efficiently retrieve specific data, modify records as needed, or even automate routine tasks. Connecting this to our overall theme, understanding GlideRecord is fundamental because it's the backbone of many scripts and workflows in ServiceNow. It empowers us to customize and extend the platform's capabilities, making it more tailored to our unique business needs. So, by mastering GlideRecord, we're unlocking a lot of potential for automation and data management within ServiceNow. So let's take a closer look at what GlideRecord actually is. Essentially, GlideRecord is a powerful class within ServiceNow that acts as the bridge between your scripts and the database. It simplifies the way you interact with data by abstracting away complex SQL queries into easy-to-use methods. This means you can perform operations like querying, updating, or deleting records without needing to write intricate database code. Now, why is this important? Well, using GlideRecord not only makes your code more readable and easier to maintain, but it also reduces the amount of code you have to write. Plus, it comes with built-in security and data access controls, which helps ensure your data remains safe and compliant. When we talk about the benefits of using GlideRecord, these features really stand out. It streamlines the development process, makes your scripts cleaner, and helps you focus on what really matters, solving business problems, rather than getting bogged down in database details. So, in the context of our overall theme today, building efficient, secure, and maintainable ServiceNow scripts, understanding GlideRecord is fundamental. It's the core tool that empowers you to work with data effectively and confidently. All right, let's talk about setting up your environment for working with GlideRecord. First, you'll need to access the script editor. In ServiceNow, you can do this by navigating to System Definition and then selecting Script's background. Alternatively, you can also use a fixed script if you prefer. This is where all the magic happens, so it's important to know exactly where to go. Now, before you start writing your scripts, there are some prerequisites to keep in mind. Most importantly, make sure you have the appropriate roles and permissions. These permissions allow you to access and modify the tables and records you'll be working with using GlideRecord. Without the right permissions, you'll run into access issues, so it's worth double-checking. Another key point is understanding the script execution context. This is crucial because the context determines what your script can do. For example, client-side scripts run in the user's browser and have limited access, while server-side scripts run on the server and have broader access to the database. When working with GlideRecord, you want to ensure you're in the server-side context, since that's where GlideRecord is most effective. To sum up, setting up your environment involves knowing where to find the script editor, ensuring you have the right permissions, and understanding the execution context. Getting these basics right will set a solid foundation for your scripting tasks and help you avoid common pitfalls. Let's take a look at some basic GlideRecord operations. These are essential methods for working with data in ServiceNow. For example, add query helps us specify search criteria next, allows us to iterate through records, update, modifies existing records, insert, adds new records and delete record, removes records. Understanding these methods is key to effective data manipulation. To get started, we need to instantiate a GlideRecord object. This is done with new GlideRecord table name, where you replace table name with the actual table you're working with. This creates a reference point to that specific table in the database. Once we have our GlideRecord object, executing a query is straightforward with the query method. This retrieves all records that match any set criteria. To see the results, we can simply display the records using GS.info, which outputs the data to the system logs. By mastering these basic operations, you'll be able to perform most data-related tasks efficiently within ServiceNow. They form the foundation for more complex scripting and automation, so it's important to understand how to create queries, navigate records, and manipulate data effectively. Now let's move on to part 2, where we focus on creating and initializing a GlideRecord. This is a crucial step because, as you know, GlideRecord is the backbone of scripting interactions with ServiceNow tables. To start, we need to decide which table we're working with, and that's done by creating a new GlideRecord object for that specific table. Initializing it correctly ensures we're working with the right data set from the beginning. Think of it like opening the right folder before you start looking for documents. Once we've created the GlideRecord object, we often use the add query method to filter records, or initialize if we're preparing a new record to be inserted. This step ties into the overall theme of efficient data handling, making sure our scripts are precise and effective from the start. Proper creation and initialization set the stage for successful data retrieval or modification, which is essential in automation and customization within ServiceNow. All right, let's talk about instantiating a GlideRecord. When you're working with a specific table, like the incident table, you create a GlideRecord object to interact with it. For example, you would write var inc equals new GlideRecord incident. This line creates a GlideRecord object specifically for the incident table, and it's a common starting point when you're dealing with incident-related operations. You can also create an instance for any other table by replacing table name with the actual name of the table you're working with. So, the general syntax is var gr equals new GlideRecord table name. Now, the table name itself is really important because it tells GlideRecord which table to operate on. Make sure you use the correct table name, because if you get that wrong, your code won't work as expected. To sum up, instantiating GlideRecord is about creating a new object tied to a specific table by passing that table's name as a parameter. This is the foundational step for querying, updating, or manipulating records within ServiceNow. Now let's look at how we initialize a GlideRecord for existing records. When working with records, it's important to handle cases where the record might not actually exist. To do this, we use an if statement combined with gr. Next, if the record is found, we can proceed with our logic inside the if block. If not, we want to log or handle that scenario gracefully, so we include an else clause with GS.info indicating that the record was not found. Next, I want to highlight how we retrieve a specific record using the get method. We start by creating a new GlideRecord for the incident table with var gr equals new GlideRecord incident. Then, we use get sysID of record to fetch the record with the particular sysID we're interested in. This get method is quite efficient when you already know the sysID because it directly retrieves that record without needing to iterate through multiple records. It's a straightforward way to access a known record quickly. So, combining these points, always remember to check if the record exists with if gr. Next, when you're not certain about its presence and use get. When you know the sysID, This approach makes your code more robust and reliable. Let's talk about some best practices for initialization that can really improve your code quality and robustness. First, it's a good idea to use constants or configuration values for your table names. This makes your code much more maintainable and less prone to errors, especially if you need to update a table name later on. Instead of searching through your code to find every instance, you change it in one place. Next, always remember to check for null or empty values before using get or similar methods. For example, validate your SysID or other identifiers before you proceed. This helps you avoid unexpected behavior or runtime errors that can be tricky to troubleshoot. And when you're dealing with external data sources or user inputs, implementing try-catch blocks is essential. They allow you to handle exceptions gracefully, providing a smoother experience and avoiding crashes during initialization. Lastly, avoid hard-coding table names directly in your code. Instead, store them in constants or configuration files. This makes your code cleaner, easier to update, and more adaptable to changes down the road. By following these best practices, you'll write more reliable, maintainable, and error-resistant code, which is key to successful system initialization and overall stability. Now, let's move on to the next part of our journey, querying records with GlideRecord. In this section, we'll explore how to retrieve specific data from your database efficiently. GlideRecord is a powerful tool that allows us to perform database operations directly from scripts. We'll cover the key points, such as creating a new GlideRecord object, setting query conditions, and executing the query to fetch records. Understanding these basics is essential because it forms the foundation for building dynamic, data-driven applications within ServiceNow. By mastering GlideRecord, you'll be able to interact with your data more effectively and tailor your applications to meet specific needs. So, let's dive into how this works in practice and see it in action. Now let's look at some basic querying techniques, starting with the addQuery method. This method is fundamental for building queries in ServiceNow. For example, if you want to find incidents that are assigned to a specific user, you can use incident, addQuery, assigned to GS, get user ID. This line filters incidents to only those assigned to the current user, making it very practical for user-specific views. The addQuery method requires 3 parts: the field name, the operator, and the value. For instance, you might use addQuery field name, operator, value. The operator can be things like equals, or contains depending on what you're trying to match. What's important to remember is that addQuery adds a condition to your overall query. It's very versatile because it supports various operators and field types, allowing you to create complex and precise searches. Connecting this to the overall theme, mastering addQuery, is key to effectively querying data within ServiceNow, enabling you to filter and find exactly what you need efficiently. Now, let's explore some advanced querying techniques that can really enhance your filtering capabilities. First, when combining multiple conditions, you can use logical operators within add-encoded query, or chain multiple addQuery calls. This approach allows you to create complex and or conditions, giving you precise control over the data you retrieve. Next, constructing complex queries often involves combining several addQuery calls, or you might choose to use add-encoded query for more advanced filtering needs. For example, you can query based on date ranges or multiple specific conditions simultaneously, which is especially useful when dealing with more intricate data requirements. Finally, the add-encoded query method is particularly powerful because it lets you work with encoded query strings. This is very useful when you've built complex filters using the filter builder, as it enables you to incorporate those sophisticated queries directly into your script. Overall, mastering these advanced techniques allows you to craft highly tailored queries, making your data retrieval more efficient and precise, which is essential in leveraging the full potential of the platform. Now, moving on to executing the query. The key thing to remember here is that the query method is what actually runs the search after you've set up all your conditions. Without calling query, no data will be retrieved, so it's a crucial step. When we talk about using the query method, it's important to understand that it triggers the retrieval of data based on what you've specified. But just writing the query isn't enough. Optimizing it is essential, especially when dealing with large datasets. Some practical tips include using indexes to speed things up, avoiding wildcard searches at the beginning of your search string because they can slow down performance, and limiting the number of returned fields to only what you need. These small adjustments can make a big difference. Understanding how query execution works helps us appreciate why these optimizations matter. The query function retrieves all records that match your criteria, which can become a performance bottleneck if you're not careful. So, always think about how to make your queries more efficient, particularly when working with large tables. This will ensure your applications run smoothly and efficiently. Now, let's move on to the next part of our journey, traversing the results set. In this section, we'll explore how to efficiently navigate through the data we've retrieved. Think of it as walking through a list of results, understanding how to access each item, one by one. This is a crucial step because once you have your results set, the real work begins, processing or displaying that data to your users. We'll cover key techniques such as using cursors or iteration methods, which allow you to move seamlessly through your data. Remember, the goal here is to do this efficiently, especially when working with large datasets. Connecting this to our overall theme, mastering results set traversal is fundamental to building robust and scalable data-driven applications. So, let's dive into the practical ways to traverse and handle your results sets effectively. Let's take a look at how the next method works in practice. In this example, we're displaying incident numbers by looping through each incident record. The code uses a while loop that continues as long as incident next returns true. Inside the loop, we simply output the incident number with GS, info, incident, number. This approach is a common way to traverse through records one by one. The key point here is that using a while loop with next allows us to process each record individually and efficiently. Now, what exactly does the next method do? It moves the GlideRecord pointer to the next record in our results set. If there is a next record, it returns true, allowing the loop to continue. If we've reached the end of the set, it returns false and the loop stops. Understanding this is essential because it helps us control the flow of record processing, especially when working with multiple records in ServiceNow. It's a fundamental part of handling data dynamically and effectively within our scripts. Now, let's look at how we can access field values in ServiceNow, starting with an example involving the assigned user's name. When we write GS, info, incident, assigned to getDisplayValue, what we're doing is retrieving and displaying the name of the user assigned to that incident. This is really useful when you want to show user-friendly information on your forms or reports. Next, it's important to understand the difference between getDisplayValue and getValue. The getDisplayValue method returns a formatted, human-readable version of the field, like a user's display name or a date in a friendly format. It's perfect for UI purposes because it shows information in a way that's easy to understand. On the other hand, getValue gives you the raw, unformatted data. For example, it might return a SysID or a date-time value that isn't immediately meaningful to users without further formatting. Knowing which method to use depends on what you need, whether it's the user-friendly display or the raw data for processing. So, to connect this to the overall theme, mastering these methods helps you control how data is retrieved and presented, making your scripts both more effective and more user-friendly. Let's talk about checking if records exist in your data. First, it's important to be cautious with the getRowCount method. While it can tell you the total number of matching records, it can also be resource-intensive, especially on large tables. So it's best to use it sparingly. Instead, consider alternatives like using the query method and checking if next returns true. This approach tends to be more efficient and performs better. Now, getRowCount does have its uses, mainly when you need to know exactly how many records match your criteria. But if all you want to know is whether any records exist at all, checking if next returns true is usually sufficient. Earlier has next was commonly used for this purpose, but it's now deprecated. Instead, we now prefer using a simple while next loop, which effectively handles the same job without the extra overhead. In summary, for best practices, avoid overusing getRowCount on large datasets and lean towards using query with next checks for better performance. This helps keep your code efficient and responsive as part of your overall data handling strategy. Now, let's move on to the next part of our discussion: inserting, updating, and deleting records. This is a crucial aspect because it allows us to manipulate data within our databases effectively. When we talk about inserting records, we're essentially adding new data entries into a table. Updating records, on the other hand, involves modifying existing data to keep it current or correct. And deleting records allows us to remove data that is no longer needed, helping us maintain a clean and efficient database. These operations are fundamental for managing dynamic data and ensuring our databases accurately reflect real-world changes. Throughout this section, we'll explore how to perform these actions safely and efficiently, connecting them to the broader theme of database management best practices. Now, let's talk about how to insert new records into our database. The first step involves using the initialize method. This creates a brand new record and also sets some default values automatically, which helps streamline the process. Once we have our new record, we need to set specific values for its fields. That's where setValue comes in. With setValue, we can assign a particular value to a specific field, customizing our record as needed. Moving forward, before we actually add this record to the database, we need to populate its fields. We do this by calling setValue for each field, specifying the field name and the value we want to assign. This step ensures our record has all the necessary information before saving it. Finally, to save the record, we use the insert method. This method commits the new record to the database, and, importantly, it assigns a unique SysID to that record. This SysID is crucial because it uniquely identifies our record within the system. By understanding these steps, initializing, setting field values, and inserting, we can efficiently add new records and make sure they are properly configured and uniquely identifiable. This process is fundamental to managing data effectively within our overall system. Let's now look at how to delete records using the GlideRecord method. Before you proceed with deleting any data, it's crucial to consider a few key points. First, make sure you have the necessary permissions to perform deletions, as this is often restricted to prevent accidental data loss. Second, think about the impact of deleting a record, especially how it might affect related data or ongoing business processes. You don't want to delete something that could cause issues elsewhere in your system. When you're ready to delete, the first step is to retrieve the specific record you want to delete, just like you do when updating. You can retrieve it using GET, or a query to make sure you have the exact record in hand. Remember, the GlideRecord method permanently removes the record from the database, which means once you delete it, it can't be undone. This is a powerful action, so always double-check before executing it. Understanding these points helps ensure you're deleting data responsibly and safely, fitting into the overall management of your data lifecycle. Let's dive into some advanced GlideRecord techniques that can really elevate your scripting skills. In this part, we'll explore methods to optimize your database queries, making them more efficient and powerful. For example, you can chain filters to narrow down your results precisely, or use functions like addQuery and setLimit to control your data retrieval. These techniques help reduce processing time and improve performance, especially when working with large datasets. As we continue through this presentation, keep in mind how mastering these tools connects back to building scalable, robust applications. By the end of this section, you'll have a solid grasp of how to leverage GlideRecord more effectively in your projects. Let's talk about chain queries and their benefits. Imagine you're trying to find incidents created by a specific user. Instead of writing complex SQL joins, we can use chained queries to make this process simpler and more intuitive. Chained queries allow us to navigate through complex data models more easily, improving both the readability and maintainability of our code. The key idea here is that we use the result of one GlideRecord query as the input for another. This is especially useful when dealing with data relationships that are interconnected. For example, first, we might query the user table to find the SysID of a particular user. Then, we take that SysID and use it to query the incident table for incidents that this user created. This approach helps keep our code clean and logical, making it easier to understand and modify later on. Overall, chained queries are a powerful tool for working with complex data, allowing us to break down big tasks into manageable steps. Now, let's talk about using display values in queries. When you're querying data, sometimes you want to base your search on what the user sees, the display value, rather than the underlying system ID. That's where querying with display values comes in handy. However, it's important to recognize the limitations. Queries based on display values can be slower, especially when dealing with reference fields, because the system needs to translate those display values into the corresponding SysID behind the scenes. So, use them thoughtfully and avoid overusing them in performance-critical situations. So, when should you actually use display value queries? They're particularly useful when you need to perform a query based on user input, where the user is providing a friendly name or label, or when you don't have the SysID readily available. This makes your queries more intuitive and user-friendly. One neat trick is that you can add display values directly to your queries using the addQuery method. For example, display value. This approach allows you to query based on what the user sees, and the system will handle translating that into the correct SysID behind the scenes. To sum up, use display value queries when it makes your querying more straightforward or user-centric, but always be mindful of their performance implications. Let's talk about GlideRecord and security. When working with scripts, it's crucial to keep security in mind at all times. You want to be aware of the access control lists, or ACLs, that are in place and make sure your scripts don't accidentally bypass those security controls. It's a good practice to validate user roles and permissions before performing any sensitive operations. This helps ensure that only authorized users can access or modify specific data. Now, understanding ACLs is fundamental. They define what users can read, write, or create and delete within tables and fields. Essentially, ACLs are at the core of ServiceNow's security model, guiding what users are allowed to do. And remember, GlideRecord respects these ACLs. So, when you run a GlideRecord query, it automatically enforces those permissions. This means users can only access and modify data they are explicitly authorized to see or change. Keeping this in mind helps us build secure and reliable scripts that align with the overall security policies of our platform. Let's take a closer look at performance optimization. In this part, we'll explore how fine-tuning various aspects of our system can lead to better efficiency and faster response times. It's all about identifying bottlenecks and applying targeted improvements. We'll discuss key techniques such as code optimization, resource management, and leveraging caching strategies. These methods help ensure that our applications run smoothly under different loads. Performance optimization is a crucial piece of the overall puzzle because it directly impacts user experience and system reliability. By understanding and applying these principles, we can make our solutions more robust and scalable. So, as we continue, keep in mind how these strategies connect to creating high-performing, resilient systems that meet our goals. When working with databases, it's really important to avoid some common pitfalls that can affect performance. One major issue is dealing with large result sets. If your queries return too much data at once, it can slow everything down. So always try to minimize the size of your result sets by using specific query criteria. For example, narrow down your search with precise filters. Also, consider using pagination techniques to break up large results into manageable chunks, which helps keep the system responsive. Another key point is optimizing your queries. Inefficient queries, those that take too long or consume too many resources, are a big problem. To improve them, make sure you're using indexes properly. This helps the database find data faster instead of doing full table scans, which can be very slow. Also, limit the number of fields you return. Don't fetch more data than you actually need. This reduces the load on the server and speeds things up. Lastly, be cautious about running queries without limits on large tables. If you don't specify a limit, you might end up retrieving huge amounts of data unintentionally, which can consume excessive resources and impact overall performance. Always set appropriate limits to keep your database operations efficient and your system running smoothly. By keeping these principles in mind, you'll be better equipped to write efficient, scalable queries that support the overall goal of effective data management. Let's talk about using indexes effectively. First, you want to leverage the table configuration to manage your indexes. This means adding indexes to fields that you frequently use in add query operations, which can significantly speed up your queries. When creating and managing indexes, it's important to identify which fields are used most often in your searches. By adding indexes to those fields, you can improve overall query performance. Now, so what exactly are indexes? They are data structures that help the database find data faster. Instead of scanning the entire table, the database uses indexes to quickly locate the records you need. This is especially useful in large datasets, where performance can really matter. So, in summary, by pinpointing the right fields and managing indexes properly, you can make your database operations much more efficient and responsive. Let's talk about limiting result sets. When working with queries, it's important to be mindful of how many records you're pulling back. Using set limit can be helpful, but I always advise caution. Why? Because it can sometimes mask underlying performance issues. Instead, it's better to focus on optimizing your queries first to make sure they're efficient. Now, to handle large data sets more effectively, pagination techniques are a great way to go. By implementing pagination, you retrieve data in smaller, more manageable chunks. This approach significantly improves your application's responsiveness and user experience. And speaking of set limit, this method is straightforward. It caps the number of records returned. It's particularly useful when you want to prevent a large result set from impacting your system's performance. But remember, while it's handy, it shouldn't be your only strategy for managing data loads. Always aim to optimize your queries first and use set limit as a complementary tool to control result size. Let's take a closer look at GlideRecord best practices and tips. In this section, I'll share some key strategies to help you make the most of GlideRecord in your projects. First, always aim to write efficient queries by specifying only the fields you need. This reduces unnecessary data retrieval and improves performance. Next, remember to handle your queries asynchronously when possible, especially with large datasets, to keep your application responsive. It's also important to use proper error handling, checking for nulls and catching exceptions, to make your scripts more robust and reliable. Additionally, consider caching results when data doesn't change often, which can significantly speed up your workflow. And finally, always test your queries thoroughly in a development environment before deploying them into production. These best practices not only optimize performance, but also help maintain a clean, manageable code base. Connecting these tips to our overall theme, they're about writing smarter, more efficient scripts that support scalable and sustainable ServiceNow solutions. When it comes to code readability and maintainability, there are a few key practices I always emphasize. First, consistent code formatting is essential. By following a uniform style, your code becomes much easier to read and understand at a glance, which is crucial when you're working on complex projects or collaborating with others. Next, commenting your code is incredibly valuable. Adding clear comments that explain what each GlideRecord operation does helps others, and future you quickly grasp the purpose of the code without having to decipher it line by line. And of course, using proper naming conventions is a game changer. When you choose clear, descriptive names for your GlideRecord variables and methods, your code naturally becomes more readable and much easier to maintain over time. Overall, these practices not only make your code cleaner, but also support the broader goal of creating reliable, scalable, and easy-to-manage solutions that fit into the bigger picture of effective development. Let's talk about error handling, which is a crucial part of building reliable applications. First, it's important to log errors. This means capturing what went wrong and recording it in the system log. Doing this helps us troubleshoot issues more effectively and keeps an eye on the health of our system over time. When an error occurs, we want to understand what happened and resolve it quickly, and logging plays a key role in that. Next, we need to implement graceful error handling. Instead of letting our scripts crash unexpectedly, we use techniques like try-catch blocks. These allow us to catch exceptions, those unexpected errors, and handle them gracefully. We can then display informative messages to users, so they understand what's happening without confusion or frustration, and we also prevent data corruption or loss. Overall, combining error logging with try-catch blocks gives us a robust way to manage errors. It ensures our applications are more stable, easier to troubleshoot, and better at providing a good experience for our users. This is aligned with our overall goal of creating reliable, user-friendly systems. Let's take a moment to review some security best practices that are crucial for maintaining a strong security posture. First, it's essential to regularly review your code for vulnerabilities and ensure that it complies with your security policies. This ongoing process helps catch potential issues early before they can be exploited. Next, a key point is avoiding hard-coding credentials directly into your scripts. Instead, always use secure storage mechanisms like credential stores or environment variables. This way, sensitive information isn't exposed in your code, reducing the risk of leaks. Additionally, always validate user input to prevent injection attacks and maintain data integrity. By thoroughly checking what users submit, you can prevent malicious data from compromising your system. Connecting these points to our overall theme, consistent review and proper handling of credentials and input are fundamental to building secure, resilient applications. These practices not only protect your systems, but also foster a security-aware development culture. Let's wrap up with some key takeaways. Throughout this presentation, we've explored how critical it is to understand the core concepts and their practical applications. Remember, the main idea is to connect these points to the bigger picture, how they fit into our overall goals and strategies. By doing so, we can ensure that what we've learned today isn't just theoretical, but something we can actively implement. Keep these insights in mind as you move forward, and think about how they can influence your decisions and actions in real-world scenarios. This concludes our discussion, but I encourage you to reflect on these ideas and continue building on them. Let's take a moment to summarize the key points we've discussed. First, continuous learning is essential. ServiceNow is always evolving, so staying up to date with the latest features and best practices will help you maximize the value of your investment. It's important to keep learning so you can leverage new tools and improvements as they come. Next, we talked about the importance of efficient data handling. Proper data management is crucial for maintaining the performance and stability of your ServiceNow instance. Handling data efficiently ensures your system runs smoothly and reliably, which is vital for your daily operations. Finally, we revisited GlideRecord concepts. Remember, GlideRecord is a powerful tool for interacting with your ServiceNow data. Gaining a solid understanding of its features and best practices is key to developing efficiently and avoiding common pitfalls. Overall, these points tie back to our theme of effective ServiceNow management. Staying current, handling data wisely, and mastering core tools like GlideRecord will set you up for success. Now, let's explore some further resources that can really help you deepen your understanding. First, the ServiceNow community is a fantastic place to connect with other users and developers. Engaging with this community allows you to learn from real-world experiences and share your own insights. It's a great way to stay updated and troubleshoot issues. Next, consider pursuing official ServiceNow training and certification. These programs are designed to boost your skills and knowledge, making you more confident in working with the platform. Earning certifications can also enhance your professional profile and open up new opportunities. Finally, always refer to the official ServiceNow documentation. It's a comprehensive resource that provides detailed information on GlideRecord and other features. Whenever you're working on a project or facing a challenge, this documentation can be your go-to guide for accurate and in-depth information. Remember, utilizing these resources not only helps you learn faster, but also connects you to a broader community and official support that can make your ServiceNow journey much smoother. Now we come to the Q&A section, where I encourage you to ask any questions you might have. This is your opportunity to clarify any points or explore topics further. When addressing your inquiries, I'll aim to provide clear and concise answers, and I may include some code examples or practical demonstrations to help illustrate the concepts. Next, I want to take a moment to thank you all for your participation today. Your engagement really helps deepen understanding, and I want to emphasize how important GlideRecord is in ServiceNow development. It's a fundamental tool that enables dynamic data handling and automation, making your workflows more efficient. Finally, I'll open the floor for questions. Feel free to ask about anything related to GlideRecord or the topics we've covered. This is your chance to clarify doubts, explore best practices, or discuss real-world scenarios. I'm here to help you get the most out of this session. Thank you for watching. I really appreciate you taking the time to go through this presentation with me. I hope you found the information insightful and useful. Remember, the key points we've discussed highlight the importance of understanding the core concepts and applying them effectively. Connecting these ideas to the broader theme helps us see the bigger picture and how each piece fits together. If you have any questions or want to explore further, feel free to reach out. Thanks again for your attention, and I look forward to engaging with you in future discussions.